Ding. There it goes. Okay, so the test next week will be on the 10th, which is Wednesday. And again, it'll be a Google form that's open for 24 hours. This is what's going to be on it.
How many questions gonna be posed?
I don't know yet. I don't know yet. Okay, these are the things that are going to be on the test. Molar mass, we have already done. Percent composition, we have already done. Mole particle conversions, we have already done. We're going to do mole mass conversions today. And then, of course, mass to particles on Thursday. If you are comfortable with all this, everything is assigned. You can feel free to work ahead. Once I've gone through some example problems here, I'm going to look at that, open up that spreadsheet. We can talk about how that's going to work. I'm hoping it'll help people who are struggling with dimensional analysis see it clearer and what they are supposed to do. But I will go over that at the end. Hopefully I will be done here in about 20 minutes. So molar mass is the mass of 1 mole. Mass is measured in grams. So molar mass is grams per mole. Ladies over there, stop talking. You definitely are the ones that should be paying attention. Molar mass is always grams per mole, grams per 1 mole. And this is a conversion factor. Grams is equal to mole. There is going to be a number that goes here next to the grams. Where would I find that number? The grams per mole of an element or a compound. There you go. You would find that on the periodic table. So if I wanted to know what the molar mass of, somebody give me an element, any element, oxygen. What is the molar mass of oxygen? It is 16 what's? Grams per mole. This is a conversion factor, by the way. And it is 16 grams per mole. We're going to round all those numbers to a whole number. No point making this more difficult than it needs to be. So we'll just deal with whole numbers. But then don't look at it when you're worried about significant figures. All right. Let's go ahead and do a compound. Let's do baking soda. NaHCO3 is baking soda. That is sodium bicarbonate. What is the molar mass of sodium bicarbonate? I have a Slim Jim. I don't have any candy, but I have a Slim Jim for the first person who can answer this question. Hey, yo, you said you was putting them out. What is the molar mass of sodium bicarbonate? How would you calculate that? Calculate. Yep. Well, I mean, unless you can do it in your head. Sodium is, I have 1 of them, and it has a mass of 23. Yeah, no, I don't have time to wait. I'm not here all day. I'm not going to wait around for you guys. Hydrogen, I have 1 of them, and it has a mass of 1. Carbon, I have 1 of them, and it has a mass of 12. Oxygen, I have 3 of them, and it has a mass of 16. Add all of those up. 3 times 16. Enter plus 12 plus 1 plus 23 gives me 84. And my final unit is grams per mole. This means if I have 1 mole of baking soda, it is going to have a mass. It is going to weigh 84 grams. This is a conversion factor that we are going to use later. No, those are easy. Like I said, this is a quick review. I've already taught this. I've already taught it several times. This is a quick review to go over it. And if you want to go over it in more detail, go watch the videos from the previous classes. All right, then we got molar mass. We got percent composition. Percent means per 100. Percent, the root word there is 100. Composition means what it's composed of. And the ingredients. And so we want to know what percent of the total is each of the elements in a compound. Percents are always calculated as the part over the whole. And in this case, is going to be the element is the part, and the whole compound is the whole. And then, of course, multiply it by 100 or move the decimal in your head, whatever it is you need to do to make that a percent. So let's do baking soda again. We've got NaHCO3. I want to know the percent of sodium in baking soda. So I can come over here. I need to put the mass of the sodium on top, which is 23. You can find that by looking at the periodic table. I just happen to have it memorized. And then the mass of the compound we did on the previous piece of paper is 84 grams. Do your math. 23 divided by 84 gives me this 0.278095. Okay, Miss, do I round? Yes, you round. You round to significant digits. Since I'm letting you round these masses, don't worry about significant digits. Just round it to the whole number. So it would be 27%. If you wanted to find the percent of hydrogen, it would be 1, because that is the mass of hydrogen, over 84. And so that would be 1.2, so we'll just call it 1%, et cetera, et cetera, et cetera. If you wanted to know the percent of oxygen, you would have to multiply the 3 oxygens. And so it would be 48 over 84, which would be 57%. And once you've got all of them done, they should all add up to 100, because that's what percent means. Any specific questions about percent composition?
Yeah.
Specific.
Yeah.
Okay.
So all you did was add them all together, and that's how you got 84. And then to get like the percent, you just divide.
Yes. Okay, mole particle conversions, the conversion factor. Somebody give me an example of another conversion factor that you use commonly, not in chemistry.
Oxygen.
That's an element, not a conversion factor.
H2O.
That is not a conversion factor, Norman. How about 1 dozen is equal to 12 eggs? How about 12 inches are in a foot? How about 5,280 feet in a mile? How about 2.54 centimeters per inch? All of those are conversion factors. Particle mole conversions. These are the ones where you use Avogadro's number, the conversion factor you use to change these units, because again, we're not changing the substance, the amount of substance, we are just changing the unit that we're using to manipulate it. 1 mole is equal to 6.02 times 10 to the 23rd particles. Give me an example of a particle in chemistry. These are all particles. If you do not know what particles in chemistry are, you seriously need to go back to 8th grade.
Atoms.
Formula unit is the term applied to a ionic compound, molecules for covalent, and then of course atoms for elements. This is a conversion factor. What number always goes next to the word mole? No, what number goes next to the word mole? 1. What number goes next to the word particles? Now, Norman. There you go. these numbers that are in these conversion factors, don't split them up. That's a married, I wouldn't say a married couple, but married couples split up all the time. So they stick together like salt and pepper. Stink on shit, whatever. 1 mole, mole goes next to 1. 1 goes next to mole. It never changes. All right, example problem. Let's say that I have 6.12 times 10 to the 21st atoms. Quick, somebody give me an element. Helium. I have this many atoms of helium. I want to know how many moles that is. What is the first thing I do for dimensional analysis? Write the given, which I've just done here. Now I'm going to set up my box. The DA box, yes. And now I'm going to whop my gobbet. Atoms are here, so that must mean atoms has to go down here. I am converting to moles, so I'm going to put moles up here. What number always goes next to the word mole? 1. What number always goes next to the word atoms? You can really just say 6 at this point. I know where you're going with it. Okay, what mathematical operation are we going to be performing here? You are going to be dividing. Don't forget to use parentheses or it screws up PEMDAS and you get an exponent in the 40s. I have my calculator programmed, these graphing calculators, to Avogadro's number is just Z, so I don't have to type it all the time. And I get 0.010166113. Oh my God, miss, do I round? Yes, you round to significant digits. So that is 3. That is 3. So my answer needs to have 3. So my answer is going to be 0.0102 moles. Any questions about that particular problem? Let's go back the other way using the same conversion factor. So let's say this one I started out with atoms. Now let's start out with moles. I have a sample of, quick, somebody give me a compound.
H2O.
H2O is a good compound. Let's say I have 0.750 moles of water. I want to know how many molecules of water are there. I am going to write my given, put up my box. Moles are there, which means moles goes on bottom. And then molecules. Molecules and moles are not the same thing. They are not. I'm seeing a lot of people write MOL as an abbreviation for molecules, and then you think that's moles, and so then you end up putting the wrong numbers in the wrong spots, and you end up doing the math wrong. All right, what number goes next to the word mole? What number goes next to the word molecules? What mathematical operation are we performing here? Multiplication. 0.75 times alpha z. Oops. 4.515. I want it in 3 significant digits, so that is going to be 4.52. You cannot leave off that e to the 23rd. This, it may not be significant, but it doesn't mean they're unimportant. So don't forget those times 10 to the whatever. And my final unit then is molecules. Any questions about how I did any of this? Going once, twice. Okay, then let's move on to mass mole conversions. And notice I'm drawing the arrow both ways because you can go from mass to moles or from moles to mass. What?
I got one about those.
Okay.
So when you're, how do you determine the divide?
Well, because you always do the same thing, multiply across the top, multiply across the bottom, then divide, right? But you can skip one of those steps if it's all ones. Like on this one, this times 1, technically you are still performing that step, but you're still just getting this answer. Does that make sense?
Oh, yeah.
Yeah, so if you just know how to look at it, this is all I need to see. I don't need to see the next step over there where you put blah divided by blah. I don't need to see all that. So I'm hoping that you do this enough that you see this immediately and immediately know you need to divide. Not cross multiply. Okay, so doing mass to mole conversions. Again, I am not changing the amount of my substance or my sample or whatever. I'm not changing how much I have. I'm just changing the unit that I'm calling it. Like dozens and eggs and feet and inches. The conversion factor, I'm going to use this. Anybody want to guess? We already talked about it today. The molar mass. We've got grams per 1 mole. Where do I find the number that goes next to the word, to get next to the G?
On the, what is this thing called again? Periodic table.
Yes, you're going to find the information that goes here on the periodic table. The conversion factors, again, these numbers are salt and pepper. What are something that never split up? And I'm like, who's Taylor? I mean, is there like a famous couple that? I don't know.
Kanye.
Yeah, these are gonna stick together like Kanye and Kim. There you go. Okay, but this number will always go next to the G, and what number always goes next to the word mole? 1. Okay, so let's use this conversion factor to do some practice problems. Let's say I have a sample of 11.2 grams of sulfur. I want to know how many moles is there. I have a sample of sulfur and it has a mass of 11.2 grams. I'm making this up. I want to see how many moles that is. So I wrote my given. I set up a box. I walk my goblet, put grams here, and I'm converting to moles. So I'm going to put moles up here. It's just like we've been doing over and 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 over. If you follow those steps every time, you will never get these wrong. 1 goes next to moles. What number goes here, Norman? 6?
6.02.
Why? Do you see 6.02 anywhere on this page? What number goes next to the G? It is on the periodic table. So look on the periodic table and tell me what number goes there. I have it memorized, so I already know the answer. It is 32. All right, Norman, what mathematical operation are you going to perform? You are going to divide, because if you do the multiply across the top step, it's just a waste of time. Because it's times 1. So 11.2 divided by 32 gives me 0.35. Uh-oh. I need 3 significant figures. So I'm going to add a 0 to it and add my final unit. Any questions about that particular problem? All right, then let's go back the other way. Let's say I have to measure out 6.5 moles of hydrochloric acid. How many grams is that? You write your given, set up the box. I hate doing this over and over again. Like, I am so bored with this because it's so easy. And I want to know the mass. I'm going to put grams there. What number goes next to the word mole? And what number goes at the top? HCl, yeah.
HCl, and you gotta put hydrogen and chlorine and add those together.
Which is what?
Which is 36.
And you found that information on the periodic table. Yep. Okay, so 6. What was my original? 6.5 times 36 is 234 grams. Well, why are you? It's actually not correct on SigFig, so I'd round that down to 230. You round that down to 230. Okay. We will do all the way from mass to particles on Thursday. That's what the other ed puzzle is for. So if you want to go ahead and knock that one out, that's fine. You can work ahead. I would say go in order of due dates. That way you don't learn something that you can't do because you didn't learn the thing before. So go in order of due dates. And I want you to open up the spreadsheet assignment. Classwork, the mole. It says mole conversions spreadsheet. I want you to open that up. I do not. I did not spend all that time trying to make this. And when I could have just used my worksheets from last year. No, just do this. All right. First of all, take a look at the bottom of this file. You've got mole conversions practice spreadsheet. If you have yours open, that's great. If you do not, I hope you remember this later so you don't have to pester me with dumb questions. If you look down here at the bottom, it says molar mass percent composition. That's basically one worksheet. Then you got another. Then you got another, and then you got another. These are easy, in my opinion, because all you got to do is enter. You don't even have to do any math. You just got to type stuff. The mass particles, you don't know how to do yet. That's what we're going to do on Thursday. That's why this thing is not due till Friday. I would strongly suggest go ahead and go in here and do these molar mass and percent composition, mole particles, and maybe even mole mass conversions after you do today's ed puzzle. I'll do the first couple for these. Gallium, I'm going to find the molar mass of gallium, which is on the periodic table, and it is 69.723. This turns the cell red when it's wrong. I just told you that's what it was, but that's because we're rounding to whole numbers. So if you don't round it to the whole number, it's going to count it wrong by changing the cell red. So if you change it to the correct answer, it now makes your cell green. You can tell immediately if you are doing it correctly. The unit for molar mass, what is it? Why do I even bother opening my mouth? Like, seriously, we've been over this for like 2.5 weeks. What is the unit for molar mass? It's like in the title. Brandon, you want to help me out?
Molar mass is 6.0.
No, it isn't. That has nothing to do with mass. It is grams per mole. So if you write G/MOL here, it turns the cell green and you correct. However, if you just put G, it'll count it wrong because that is not the unit for molar mass. All right, benzene. You would then have to add up 6 carbons and 6 hydrogens to get the mass there. The ones I didn't expect you to really know the formulas. I gave them to you, but there are others on there, obviously, that I expect you to know how to write the formula for. We spent weeks and weeks and weeks and weeks on it. Like calcium chloride, you should know how to write the formulas. So that's how you do those. And the goal here is to have nothing but green cells. That's how I'm going to grade it. There is a link to instructions on how to do this. There is a link to a periodic table. And if you need a quick refresher on how to do molar mass, there is a link there for that. Percent composition. Now this is where it gets easy. You don't have to do any math. All you got to do is plug in the numbers where they go. So if I have carbon dioxide, that is CO2. Remember, we got to do the mass of the element over the mass of the compound. The mass of the compound is 44 grams per mole. I know that because I do this a lot. Carbon dioxide is 44 grams per mole. So now I got to do the mass of the oxygen on top. There are 2 of them at 16 each, so it's 32. That's all you have to do for those. It will automatically calculate the percent of oxygen, and it'll automatically round it to the correct number of significant figures. So you don't have to worry about points being taken off for any of that. You just have to make sure your setup is correct. If you forget that there's 2 oxygens you have to account for and you just put 1, it turns the cell red and you know you didn't do something right. Any questions about molar mass, the tab? All right, flip over then to the mole particle tab. Again, there's an instructions video on how to work in this spreadsheet, and then of course how to calculate mole particles over there. And you do the same thing we've been doing. You just set up your dimensional analysis box. All you have to do is plug in the values where you think they go. If you put something in the wrong place, it'll turn the cell red. What goes in this box that's highlighted right now? Yes, you do. What's the first thing you do when you're doing a dimensional analysis problem? Write the given. So what goes in that box right there? 1.2, and then the box next to it, the unit. And everything's copacetic, everything's green. What my God means, I'm going to put moles down here again. And I'm converting from moles to particles. In this case, it's an element, so atoms would work as well. What number always goes next to the word mole? Is there anybody in this class besides Norman? I guess not. Okay, then next to what number goes next to the word atoms? There you go. Now you can use the 6.02. However, you need to put it in this format. I gave you the format there. Just copy it exactly as it is. If you try to write with the X and then exponents, you can't do exponents in sheets, so it won't do the math correctly. So if you put it in that format, it will do the math correctly. So 6.02, capital E plus sign, and then 23. And it automatically calculates your answer for you and rounds it to the correct number of significant digits. All you have to do is fill in the unit on the end. Do I need to do the second example going back the other way? Okay. That one, it gives you molecules and you're going to particles. So the first thing to do is write your given. The given is in scientific notation, so put it in that E format that we did before. And again, I gave it to you there in orange. Just copy it exactly as it is. And that was molecules that we're talking about. What my God says molecules has to go down there. Converting from molecules to moles. Number 1 always goes next to the word mole. And 6.02 E plus 23. And voila. Easy. I'm hoping this will give you a clearer idea of what you need to do when you're calculating dimensional analysis. And I need to change the instructions on that because I don't have any green and blue boxes I used to. All right, so you've got 6 questions on that one you can do. And then mole mass, that's what we talked about today. Do the same thing. It's dimensional analysis. Plug in the given at 1.05 moles. No, I'm not grading that. If you want to try it out and play with that so you don't mess it up, that's fine. 1.05 moles. I got moles here. I'm converting it to grams. The word number 1 always goes next to the word moles. The number that goes next to grams, because again, this is grams per mole, I'm going to find on the periodic table. The molar mass of sodium is 23. And hit enter, and it'll do all your calculations for you and give you the final answer with the correct number of significant digits. Does this help, you think? I think this will help for the people who have no idea where to start. Turn it in. There is a 4th tab over here that's going all the way from particles to mass. So it adds an extra step. We've kind of done them before. That's what we're going to talk about in class on Thursday. If you feel like you know how to do that, go for it and play around with it. The worst that's going to happen is that they turn red. But as long as you fix them to where they turn green before you turn it in on Friday, then who cares? Try to figure out what you're doing wrong. All right. Anybody got any questions about this mole conversions practice spreadsheet? What? It will save automatically to your drive because each of you have your own copy now. Okay. If you do not have any questions for me, you can go. Ed puzzle today, and then start working on this because this will be due Friday.